Welcome back. This is Brendan here again. Let's continue our reading with Chapter 4. Listen, follow the slides, and enjoy the content as we look at how to build an architecture that makes a total network blackout practically impossible. We're talking about real safety today, specifically how to build a system that protects your team from the inevitable human error. Let's jump in.
Chapter 4. Building a safe automation system for your network. The best safety system is one that makes dangerous mistakes difficult to make in the first place. When automation goes wrong, at 3:47 a.m. on a Tuesday morning, a financial services company pushed a routine network update to their data centers. Within 8 minutes, 2,400 automated trading systems went offline. The company lost the ability to process transactions for 6 hours. The incident cost approximately $18 million in lost revenue and regulatory fines. The problem wasn't the change itself. The configuration update was correct and had been tested. The problem was that a junior engineer, working late and fatigued, ran the automation script against the production network instead of the test network. There was nothing in the system to stop this from happening. The engineer simply typed the wrong command, pressed enter, and within minutes, trading floors across Europe couldn't access the network. This chapter explains how to build an automation system that prevents these disasters, not through better training or stricter procedures, but through architecture that makes dangerous mistakes physically difficult to make in the first place. What we're building and why. Think of network automation like the systems that control a modern airport. Planes take off and land safely thousands of times per day, not because pilots never make mistakes, but because the system has multiple layers of protection. Air traffic controllers verify clearances. Automated collision avoidance systems monitor the sky. Standardized flight plans are validated before the engines even start. In network automation, we need the same thing. We need an environment where a single typo at 3 a.m. cannot destroy the business. The 5 requirements that cannot be compromised. To build a safe, professional system, your architecture must satisfy 5 specific requirements. These are not nice-to-have features. They are the foundation of enterprise-grade automation. 1. Making dangerous actions difficult. The system must have physical constraints that prevent people from accidentally doing the wrong thing. For example, a car shouldn't allow you to engage the starter motor whilst the engine is already running. In our world, this means the automation tool should be technically incapable of connecting to the production network unless it has passed through specific safety checks. The source of truth, blueprints versus digging holes. When you want to know how the network is currently configured, where do you look? Most engineers dig a hole. They log into the router and look at the settings. This is dangerous. If the router is already misconfigured, your automation will build on top of those errors. A safe system uses a source of truth, usually a Git repository. This is the master blueprint of what the network should look like. The automation always compares the real network to the blueprint. If they don't match, it fixes the network to match the blueprint. You never dig holes. You always trust the blueprints. Separation of intent and execution. The brain, the logic that decides what to change, must be separate from the muscle, the tool that actually pushes the buttons. This allows you to test your logic in a safe environment before you ever allow it to touch a real device. The safety gates. Before any change is applied to the network, it must pass through an automated assembly line with 3 specific gates. The inspector, software that reads your instructions and checks for obvious errors like a typo in an IP address. The mirror, a test environment that looks exactly like your production network, where the change is applied first to see if it causes a problem. The witness, a system that records exactly who proposed the change, who approved it, and what the results were. Visibility and audit. In a professional system, you never ask, "I wonder what changed yesterday." The system tells you. Every action is logged in a way that satisfies auditors and allows you to recover quickly if something goes wrong. Takeaway: don't train your people to be perfect. Build a system that protects them when they aren't. Why this matters for your career. Building this way is harder than just writing a script. It takes more time and requires more planning. But it's what separates a scripter from an architect. An architect doesn't just provide a tool that works, they provide a system that the business can trust with its most valuable assets. The architecture provides the safety net that allows moving faster with confidence. The architecture scales because it automates governance. At 50 devices, manual approvals and script execution work acceptably. At 5,000 devices, manual processes become bottlenecks and error sources. This architecture removes those bottlenecks by treating governance as automated enforcement, not as human process. Every compromise on these principles creates technical debt that compounds. The most expensive problems I've investigated started with someone saying, "We'll do it properly later, but right now we need to move fast." Years later never came, and the shortcuts became foundational assumptions that were expensive and risky to fix. If you implement one thing, treat your master record, Git, as the definitive source of truth from day one. Every shortcut around this principle, quick manual fixes, configuration stored in spreadsheets, temporary changes that never get documented, create a gap between what your automation thinks the network looks like and what it actually looks like. That gap is where disasters hide. The goal isn't perfection, it's recoverability. You cannot prevent all failures, but you can build a system where failures are detected quickly, contained to small areas, and recovered automatically. The difference between an incident that takes 5 minutes to fix versus 5 hours to fix is usually whether your automation architecture was designed for recovery from the beginning.
And that's a wrap on Chapter 4. The big takeaway here is that a truly safe system isn't built on human perfection. It's built on those architectural fire doors and master blueprints that catch us when we trip up. By removing that messy direct access and locking in a single source of truth, we've finally created an environment where moving fast doesn't have to mean taking big risks. I'd love to know, how are you handling your fire doors right now? Drop a comment below and let's chat about it. If you found this helpful, please subscribe to my channel and leave a comment below with your thoughts or questions. I'd love to hear how you're applying these structures in your own network. In our next session, Chapter 5, Testing Changes Safely Before They Go Live, we'll look at the actual mechanics of the testing gate and how to verify your code before it ever sees a production switch. See you in the next one.